Hey guys, again, my name is Paolo Ziguris. I'm an informatics professor. This is my YouTube channel and you are on videolearner.com. We continue our lesson about the IP datagram structure. The fields of the next line, the second word of 32-bit of the datagram. We have identification, RDF, MF, and fragment offset used in the case of splitting or fragmentation of the IP packet. Maybe we have a fragmentation of an IP packet in some segments. When the packet is going to pass through a network that is on the second level called data link level, if we have OC model or TCP/IP stack layer model, we have data link layer above physical layer. Here it is, we have a router, a network card, and cables, for example. When a network supports frames smaller than the IP datagram, we have packets, and here it is, we have another packet called frame. Then the only way to service is to split into smaller segments to smaller packets to go through the network, and at the destination to reconnect in the original IP packet. Now, these segments of the original packet are independent new IP datagram packets, or these are independent IP packets. In order for IP protocol to know which original packet it belongs to, is used a 16-bit identification field, which is the identity of the packet. Have a look here, this field is different in each packet, but same in IP packets that are segments of the same original IP packet. For example, we have ID 001, the same in 3 segments, the same as the original. In order for the destination computer to put them in the correct order, the 13-bit fragment offset field is used, which indicates the relative position of the segment, who is the first, who is the second, who is the third, for example, from the beginning of the original packet to octets. It means bytes. Now let's see which is the fragment offset formula. It's equal to n times the function of integer, and in brackets is MTU minus IHL times 4, and all of it divided by 8. And this amount is actually data, where function int means the function of the integer of maximum transmission unit is MTU, the maximum data length of the frame in the second level. Here it is, frame. Imagine that as a packet, basically is data and headings. IHL, header and header length, is the length of the header of the IP packet. Remember that is expressed in words. The fragment offset of 32-bit or for some bytes, the value that we are interested in is in a byte. Now have a look that n is 0 for the first part, 1 for the second, and so on. So for the first segment, the fragment offset is always 0. The MF and TF flags play as an important role in the segmentation process. The flags are single bits whose state is 1 or 0 and have something to say. Thus, the MF flag is more fragments, more partitions when enabled is 1, indicates that other segments follow, while when disabled 0, it indicates that is the last part of the partition packet or a single packet. If for any reason the IP datagram packet does not have to be broken or does not have to be splitted in segments, then the flag TF, do not fragment, a ban on splitting, is put in value 1. Thus, when written, the packet's MTU will be followed, which does not require splitting. Or if this is not possible, the packets will be rejected, and the sender may be notified of this action on the network. In IP version 6, packet splitting is only performed by the source computer based on the smallest MTU of the path MTU or PMTU, and not by the intermediate routers. The process of fragmentation in IP version 4 is described in more detail in the next example. In the next line now, the 8-bit field time to leave TTL starts with the sender with an initial value, usually 64, and each router from which the packet passes reduce the value by 1. When the value is 0, the IP packet is discarded and is returned to the sender diagnostic error message, time exceeded. Each passage of a packet from a node is designated a hop, so this field can be characterized and as a reverse hop counter, counts hops. Practically, this field functions as the limit of rejection of the packet. When this is delayed, it is lost in the route or an error has occurred with the destination address and wandering aimlessly in the network. Here it is, wandering aimlessly in the network. So we have an error. This field uses the trace route or trace earth command to trace its route, to record the intermediate nodes from which the packets are passed to a destination, said successively packets with TTL initially 1, and then increases by 1. So in the first packet, the TTL field is set to 1 after decreasing by 1. In the first node is zeroed, and node drops it and reports it and records who it is. In the second packet, TTL is set to 2 and the field is 0 in the second node, and so on until some TTL value reaches the destination. In the meantime, all intermediate nodes have been recorded along the route to the destination. And that's all for now. Coming up next, the rest details of IP datagram packet structure from Spyro Ziguris, our YouTube channel, and videolearner.com. Bye bye.